Here's a short recap of Part 3 of the Frogger miniseries. First, in the player blueprint, we create the logic to move our player around the map. We'll use a branch node to check if the player is in air by using the character movement's isFalling node. Next, we'll define a custom function called CalculatePlayerRotation and call it from the true pin on our branch check. Then, we'll check if the X value is not equal to 0, and if it isn't, we'll call the addMovementInput node and pass in the Y value from the event node. After that, we'll check if the Y value is not equal to 0, and if it isn't, we'll again call the addMovementInput node, but this time we'll pass in the X value from our event node. Now we can begin to code our CalculatePlayerRotation function. We'll first add in the inputs for the X and Y values to be passed in. Then we add 4 branch nodes that check if the X value is greater than 0, then less than 0. We also check if the Y value is greater than 0, and then check if the Y value is less than 0. If any of these evaluate to true, then we use the setRelativeRotation node on the static mesh and change the Z-axis to the appropriate value to turn the player in that direction. Finally, we can code the enhanced input action for our IA_leap event. Just like before, we'll use a branch node to check if the player is in the air by using the character movement's isFalling node. Then we'll pull into the launchCharacter node and split the pins so we have individual access. We can calculate the launch trajectory by getting the right vector for the static mesh and multiplying that by a leap distance variable for the X and Y pins. We'll set the Z value to be 1000 to complete our leap code. And just like that, we've created our movement and jump code for our player blueprint. Stay tuned for Part 4.